The early developments of artificial intelligence, AI, marked a significant turning point in the history of computing. In the 1950s, researchers began exploring the concept of creating machines that could think and learn like humans. And it was during this time that the first AI program was written by Alan Newell and Herbert Simon in 1955. The program was called the Logic Theorist, and it was capable of proving mathematical theorems by using a set of rules. In 1956, the term artificial intelligence was coined by John McCarthy, who is known as the father of AI. McCarthy organized the Dartmouth Conference that year, which is widely considered to be the birthplace of AI. The conference brought together a group of researchers who shared an interest in creating intelligent machines, and they laid the foundation for the field of AI. Throughout the 1950s and 1960s, researchers made significant advances in symbolic reasoning, which involves manipulating abstract symbols to represent real-world concepts. This led to the development of early AI systems, such as the general problem solver, which could solve a wide range of problems by using a set of rules. Another area of early development in AI was natural language processing, NLP, which involves teaching computers to understand and generate human language. One of the first NLP systems was the Language Translation Project, which was launched by the US government in the late 1950s to translate Russian texts into English. Computer vision was also an important area of research in the early days of AI. Researchers sought to teach computers to recognize objects and patterns in images, which is a key aspect of human vision. In 1966, a program called the Summer Vision Project was launched to develop computer vision systems that could recognize simple shapes and objects. These early systems paved the way for the development of more advanced AI technologies, and they laid the foundation for the field of AI as we know it today. The AI winter, 1970s to 1980s. The initial optimism surrounding AI research began to wane, as researchers failed to achieve the progress they had hoped for. Many believed that AI was not living up to its promise, and the field faced a significant reduction in funding as a result. During this period known as the AI winter, researchers encountered several significant challenges. One of the biggest hurdles was the inability to create intelligent machines that could perform even simple tasks with reliability and accuracy. Natural language processing proved particularly problematic, as did computer vision and symbolic reasoning. Compounding these difficulties was the fact that the expectations for AI had been set unrealistically high. Researchers had predicted that within a decade, computers would be able to understand natural language, reason like humans, and solve complex problems. When progress failed to materialize at the pace anticipated, many researchers and investors lost faith in the field. The AI winter lasted until the late 1980s, when a new approach to AI called connectionism emerged. This approach, which focused on neural networks and machine learning, proved to be more successful in creating intelligent machines that could perform complex tasks. The renewed success of AI research eventually led to increased funding and a resurgence of interest in the field. Expert systems and neural networks, 1980s to 1990s. This was a period of time when the AI community had learned from the mistakes of the past and was more realistic in its expectations. The development of expert systems was a way to create intelligent systems that could be used for specific tasks, such as diagnosis in the medical field or decision-making in finance. These systems were based on knowledge bases that allowed them to provide advice or make decisions based on a set of rules and heuristics. At the same time, researchers were exploring the use of neural networks for pattern recognition and classification. Neural networks are computational models that mimic the way the brain works. They're made up of layers of interconnected nodes, each of which processes information and passes it on to the next layer. Neural networks were found to be particularly effective in areas such as image recognition and natural language processing. During this time, there were also significant advances in the development of machine learning algorithms, which allowed computers to learn from data without being explicitly programmed. The rise of machine learning, 2000s to 2010. A significant rise in the field of machine learning occurred, primarily due to advances in data processing and storage capabilities. Machine learning is a type of artificial intelligence that enables computers to learn from data and improve their performance without being explicitly programmed. The more data these algorithms are fed, the more accurate and efficient they become at their respective tasks. During this period, a number of machine learning algorithms were developed, such as decision trees, random forests, support vector machines, and neural networks. These algorithms were used in various applications. One of the most significant developments during this time was the introduction of deep learning, which is a subset of machine learning to learn representations of data. The current state of AI. AI has become a technology that we encounter in our daily lives. It is integrated into everything from our smartphones to self-driving cars. AI has played a significant role in many industries, including healthcare, finance, and entertainment. However, as AI technology continues to advance, so do concerns about its ethical implications. Issues such as bias, privacy, and accountability have been raised, prompting discussions and debates around the responsible use of AI. Despite these challenges, the future of AI looks promising. Robotics is one area where AI is expected to have a significant impact, with robots becoming increasingly common in industries such as manufacturing, agriculture, and healthcare. AI is also expected to play a crucial role in personalized medicine, with deep learning enabling the creation of tailored treatments for patients. Overall, AI will continue to shape our world in profound ways. While there are certainly challenges to overcome, the potential benefits of AI are too great to ignore.